So this unit is pretty algebra based. And we're covering a skill that by itself, it's not very useful, but we're going to be using it in the next couple of years to help us solve new types of equations, okay? And that's something called factoring. And there's different, and instead of factoring numbers like you guys have actually done in the past, okay, we're going to be factoring algebraic expressions. So just as a review, you don't have to know that. Hello. You don't have to know the definitions of these terms, but you should understand what they mean when I refer to them. So a polynomial is an algebraic expression consisting of one or more terms consisting of one or more terms and these terms are separated by plus minus. Where any exponents, if there are any, are whole numbers. So what it means, what you can't have fraction exponents, which we looked at in the last unit. Can't have negative exponents. So an example would be like, and you've seen these before, we reviewed it last year, 5x squared plus 6x minus 7. That's a good example. That example, or an example of something that's not a polynomial, would be like 4x to the negative 3 minus 7x to the 1/2. Can't have negative exponents, can't have fraction exponents. So we're going to be focusing on doing stuff with polynomials in this unit. So what's exactly a term? Well, it's a number, a variable, possibly with an exponent, or, given one root, the product of a number and variable. So any number, 7, negative 6.7 repeating, 1/2. All of those are terms. A variable, x, y, a, b, could have an exponent, so a squared, b to the 5th. Or the two multiplied together. So like 5x squared is a term. Okay, these last three, you should be, hopefully you remember. Monomial is a polynomial with one term. And if you know that one, can you tell me what a binomial is? Two terms. So, ditto, ditto, two terms. And it only makes sense. Trinomial would have three terms. Okay. So we're going to be throwing around these words a fair amount: polynomial, term, monomial, binomial, trinomial. Again, you should just be familiar with what I'm talking about when I refer to them. Okay. Okay. So the first thing we're going to start doing is factoring polynomials. You guys have factored before, okay? Using arithmetic numbers. So you guys have, say, multiplied 6 by 4 to get 24. Okay. Factoring is the reverse process. I give you the number, you tell me what you multiply. So if I were to factor 24, it could equal 6 times 4, and actually it could equal other things too, couldn't it? 8 times 3, 12 times 2, 24 times 1. So when you factor something, you're breaking it up into what multiplies to get what you're factoring. So if I asked you to factor 36, you're breaking it up into numbers that multiply to 36. It could be more than 2. So like 9 times 4, 9 times 2 times 2. Okay. Last year, we talked about multiplying, and I often use the word expanding. Something like this: 6 times x plus 4. So these are two expressions that you're multiplying together. What would be the answer, by the way, when you multiply those two? 6x plus 24, because we multiply 6 by everything in the parentheses. This is what we're going to focus on now in this sheet. How do we factor things like this? How do we factor 6x plus 24 and get back to 6 times x plus 4? You could have also done 8 times x plus 3, or sorry, good enough. What am I talking about? You could have done that. You could have done 2 times 3x plus 12. Somebody's a little crazy. Is that next door? So this is what we're going to focus on right here. And there's different ways to factor depending on what you're given as an expression. So we're going to look at ones like this to start with. So the first one we're going to look at is how to factor by factoring out the GCF. You remember what GCF stands for? Greatest common factor. Oh, okay. So let's say I give you something like this. I want you to factor 6x plus 15. What does that mean? That means find two expressions that multiply to get 6x plus 15, where 1 is the greatest common factor. Okay? So there's two factors. One is the GCF. Look at all the terms. Tell me what is the highest number or variable, or both, that you could divide into both of these? 3. Are there variables in both? No, so I can't divide out a variable. So that's one of my factors, 3. To find the second factor, you divide what we're factoring by the GCF you found. So what's 6x divided 3? 2x plus 5. Therefore, the answer is 3 times 2x plus 5. That's how you write it. You write it as a multiplication. So these are the steps that are involved. You don't have to write those steps. Although you may want to as you start these things, but you guys will reach the point where you'll be doing these things in your head. Okay, and you'll just be going straight to the answer. And how do I know that if this is right? Just multiply it back and see if you get this. That's the nice thing about factoring, is you can always check your work by just multiplying back and see if you get the original answer you were asked to factor. Okay, so let's just look at some different examples. Oh, before that, let's just practice getting some GCFs. What's the greatest common factor of 10x and 15? What's the highest number and or variable that I can divide out of 15? Sorry, 10x and 15. 5. What's the greatest common factor of these two? Notice they both have numbers and variables this time. Well, what's the highest number I can take out? 6. What's the highest power of a? How many a's can I divide out? There's 2 a's being multiplied here. There's only 1 here. So the most I can divide out is 1, right? So the GCF is 6 times a, or 6a. So you see, that's how we do it when exponents are involved. How about this one? 4. What else? M squared. I can take out m squared from each of them. Can't take out m to the third because there's not enough m's here. And good. How about this last one? 7. Third, yeah. You guys are always reading exponents like playing Battleship. Q to the third. P3. Yes. I don't think there's any P or Q in Battleship. Sure, player. So, okay. Okay. So now let's take that and factor some more. So again, I'm going to write the steps for the first one. Get the GCF for your first factor. Divide the original by the GCF, get your second factor. And then put those together by multiplication to get your factored answer. So what's the GCF? 3. Therefore, my second factor is going to be 6x plus 6n plus 9 divided 3. So I put these two together, and remember, these have to stay together. How do we keep them together? We put parentheses. That's the way the answer looks. Don't just stop here. You have to write both factors showing that they're being multiplied together to get 6n plus 9. Okay, let's try without writing the steps. What's the GCF? Is that it? 2c. And the other factor is when I divide these by 2c. 3c minus sure? Power 2. Okay. I'm going to check this one by multiplying. This times this is 6c squared.
Oh, it's 3.
This times this is 6c cubed. So it looks like I wrote too many c's.
3.
So the answer should be 3 minus 2c. Again, if you're not comfortable going to that step right away, then break it up like this. Okay? Try the next one on your own or with somebody else. When you factor by the GCF, your answer is always going to look like something times something in parentheses. First of all, what's the GCF? 5. And then our second factor is always going to be in parentheses. Now we have to do 3 divisions. Be careful. 5 divided 5 should be a 1 there. Minus 2z plus
To the z power 2.
z squared. Excellent.
Wait, I have a question.
Yes.
Do you take out the 1 after you divide it for the z power 2? Because if you divide 5 by 5, it's going to be 1.
Yes. That's why we have a 1 here.
And for the second one, you
Oh, for the z squared? Well, 5z squared divided 5. 5 divided 5 is 1 z squared. And you don't have to write the 1. If you did, you're fine. This last one, just something to look out for. What's different about this one than the other 3? What do you notice that's different about this one than the other 3? It's got a negative at the front. Whenever there's a negative at the front, you always have to factor out as your GCF a negative. So just keep in mind, we're going to be doing negative. And then what's the GCF? 4. What's the maximum number of x's I can take out? Just 1. So x y squared. And now I got to do 3 divisions. You may want to just do this to help you. Some students do this. They get the GCF, they get their final answer set up, and then they just show the division here just because we got a lot of numbers and variables going on here. So what's negative 12 x to the third y to the third divided negative 4 x y squared?
3x to the y.
3x squared y, not to the y. Plus 20xy squared divided GCF.
5y.
Subtract 5 y x. What's x divided x? It's just subtract 5. X divided x is 1. Y squared divided y squared is 1. So really, we're just left with 5 times 1 times 1, which is just 5. Finally, the last division. Plus 4x. Because y squared divided y squared is 1, and times 1 we don't have to write it. And again, you can always check your answers by multiplying back through to see if you got it right. That's the beauty of factoring. Any questions? Yeah.
Are you subtracting the exponents or dividing?
Yes. What? Oh, sorry. I thought you said, are you subtracting the exponents? You're subtracting the exponents, yes. Okay.